Welcome back. So we're continuing on with isosceles triangles. We're going to look at some examples. We want to remember that our legs are exactly the same length. Our two base angles at the bottom of the legs are exactly the same measure. We can find the third vertex angle by remembering that the three angles add up to 180. Okay? All right, so let's look at some examples. When I look at number 1, the first thing I always like to do when I'm working with isosceles triangles is identify where my legs are and where those congruent base angles are. So my two legs are going to be the two that have the tick marks. A leg here and a leg here, and then at the bottom of the legs, that's where my base angles are going to be. So one base angle is 3x, the other base angle is also 3x. Okay? So if I'm trying to find out what x is, then I know the three angles in a triangle always add up to 180. So 3x plus 3x plus 90 will add up to 180 degrees. I'm going to go ahead and combine, that's using my triangle sum theorem if I was doing a proof. Okay? All right, so then 3x plus 3x is 6x. Plus 90 equals 180. Then I'm going to take away 90 on both sides, my subtraction property of equality. And I get 6x equals 90. My division property of equality, divide both sides by 6, and x equals 90 divided by 6, which I believe is 15, but I'm going to double check it with my calculator. Yes, it is 15. Okay, oops, y'all couldn't see all of my work there. There we go, 15. So I took my three angles, I added them together to equal 180, and then I simplified, solved for x. Another way we could have done that is kind of reasoned it out, used a little bit of logical reasoning, where he said, okay, if this one's 90 out of my 180, that means there's going to be 90 degrees left that I have to divide among these two angles. So 90 divided into two angles is 45. So that means this 3x is 45 and this 3x is 45. So if 3x equals 45, 45 divided by 3 would also give me 15. So you can do it either way. Let's look at number 2. On number 2, I see I have two angles that are congruent. That means those are the bases. So that means this triangle is really kind of turned sideways if I wanted to look at it like a traditional isosceles triangle, where if these are the bases, that means this down here is my base, where these two angles belong. So that means these two are my congruent legs, which means those have equal measures. So this piece is equal to this piece. My 3x minus 6 is equal to my 2x plus 6. Okay? Then when I go to solve this, I'm going to subtract 2x to get all my x's on the same side of the equals. So I end up with 3x minus 2x is just 1x minus 6. 2x minus 2x is 0 plus 6. Sometimes when we see a minus 6 and a plus 6, we just change it to a 0. But notice they're on different sides of the equal, so I can't just combine them. I do have to add this 6 to the other side. And I end up with x plus 0, which is just x, equals 6 plus 6, which is 12. We can check our work by plugging it back in. 2 times 12 is 24. 24 plus 6 is 30. 3 times 12 is 36. 36 minus 6 is also 30. So both of my legs here have a measurement of 30 units when x is 12. Okay, let's look at number 3. So again, number 3 is very much like number 1, where there's the two methods to do it. I like to do it very algebraically, but you can also kind of reason through it where I have 90 degrees, so then I split what's left among the two bottom angles. I'm going to go ahead and do it algebraically because that's just the way my mind thinks. I have my two legs, a leg here and a leg here. That means this down here along the bottom is my base. So the two angles at the bottom along the base will both be the same. If this one's 5x, this one is also 5x. When I add the three angles together, I'm going to get 180 degrees. So 5x plus 5x plus 90 equals 180 degrees. Combine my like terms, 10x plus 90 equals 180 degrees. Subtraction property of equality. (10x equals 90). Division property of equality. And x equals 9. Okay. We can check our work by plugging it back in. 5 times 9 is 45. 5 times 9 is 45. 45 plus 45 plus 90 does make 100. Okay? All right, let's look at number 4. Number 4 is a little bit different. Here I can see I have my tick marks, so this is a leg, and this is a leg, which means this is my base, and angle A and angle C are my congruent angles. But I can't say 6x plus 6 equals itself, 6x plus 6, because that's going to just cancel everything out. So I do have to use the three angles, and I know together they're going to add up to 180. So this angle is 6x plus 6 plus this right, so that's the left side. The right side is the exact same thing, 6x plus 6. Plus my top angle is 2x. I know all three of those together are going to make 180 degrees. Let's combine our like terms. I've got 6x plus 6x plus 2x, so that's 12, 14x. Then I've got a 6 and a 6, so that's plus 12 equals 180. I'm going to use my subtraction property of equality to subtract 12 on both sides. When I do that, I end up with 14x equals 180 minus 12 is going to be, I believe, 168. Yes, it is. My division property of equality, divide both sides by 14. 1x equals 168 divided by 14 is 12. Okay, so that is my answer for number 4. I could plug it into check. If I were to plug it into this one, 2 times 12 is 24, so this is 24 degrees. Down here, 6 times 12, I believe is 72. Yes, plus 6. So this angle is 78 degrees, which means this angle is, also 78 degrees. 78 plus 24 does make 180 degrees, so we are good. X does equal, x equals 12. Okay? All right, let's look at number 5. Number 5, again, I'm working with angles, and I want to identify where the base angles are. So when I look at this, I see my 2 tick marks. So that means my triangle is kind of on its side. This is a leg. This is a leg, which means this is my base. So these are my 2 congruent angles here and here. They are both 2x. Okay, so again, the 3 angles in the triangle add up to 180 degrees. So my 40 plus the 2x plus the other 2x equals 180 degrees. I'm going to combine these two like terms. 2x plus 2x is 4x. I have this positive 40 equals 180. Subtraction property of equality. And 4x equals 140. Divide both sides by 4. And 1x equals 140 divided by 4 is 35 degrees. Okay, I can check that. 2 times 35 is going to be, 2 times 35 is going to be 70, so this angle is 70, which means this angle is also 2 times 35, which is 70. 70 plus 70 plus 40 is 180, so it works out. Okay? All right, one more. Let's look at this last one. For the last one I have an isosceles triangle where I have two congruent sides. This is a leg, and this is a leg, which means this down here at the bottom is the base, and these two angles are both the same, so they're both x. My three angles added together add up to 180, so 3x plus x plus x equals 180. When I combine my like terms, 3x plus 1x plus 1x, 3, 4, 5 x's, equals 180. Division property of equality, divide both sides by 5, and x equals 180 divided by 5 is 36. So x equals 36 degrees. I can check that. My first angle here is 36 because x is 36. This one is 36. And then 3 times 36 is 108. And then I can check that. 36 plus 36 plus 108 does equal 180. So we are good to go. Okay? Now, most of my examples here did deal with the angles, but don't forget, they don't always add up to 180, right? They all did because I was working with angles on most of these, okay? They're all the inside the angles. Sometimes we're dealing with sides, so remember when you're dealing with sides, the legs are equal to each other. The sides will never add up to 180. One real common mistake that I see a lot, I'm going to write it on the back of this page so you can see what I'm talking about, is I'll see a lot of people who they'll see something like this, an isosceles triangle, and they'll have, I don't know, let's see, 3x plus 7, and then 2x minus, no, let's go plus 20, and then let's do x minus 4. Okay? So a lot of times people will see this problem and they'll say, oh, all three sides add up to 180. And where we go wrong is sides don't add up to 180. Okay? That's super important to remember. Sides do not add up to 180. Okay, 180 is not a side thing. 180 is an angle thing. Angles add to 180. So not sides, but angles. So here when I'm working with sides, I cannot add those three together and say they equal 180. Instead, what I do is I say, okay, this leg here and this leg here, these two, look right here, they are equal to each other. So I can set my 3x plus 7 equal to my 2x plus 20. And I don't really even need this piece down here at all. Okay? So to solve this one, I would subtract 2x on both sides. and get 1x plus 7 equals 20. Okay, subtract 7 on both sides, and x equals 13. Okay, so when I check that, I would put the 13 in here and do 3 times 13 plus 7. 3 times 13 is 39 plus 7, so this length is 39. Then I would do the same thing over here. 2 times 13. Oops. Not 39. I didn't get my plus 7 on there. 3 times 13 is 39. And then I forgot my plus 7. Makes me 46. Over here, 2 times 13 is 26. Plus 20 is 46. And this one, because I have this expression down here, I could do 13 minus 4 and find that this length is 9. But again, these three do not add up to 180 because sides don't make 180. It's just the angles, the inside. These pieces here, these two are congruent, and together with the vertex angle, the angles add up to 180. So that's just a real common mistake that I see, is sometimes we get our angles and our sides and how to work with them mixed up. Okay, so try to keep that in mind. Angles add up to 180. The two base angles are the same. Your sides can add up to any different number. Okay, it's just the perimeter, and all triangles can have different perimeters. They don't all have to be 180. Okay, so keep that in mind when working with your isosceles and really any triangle. Okay, thank you so much for watching.